All right, hey guys, this is Mr. Heeren. This is 2.5 for Algebra 2 scatter plots, and what this is going to do is kind of take what you did last time with linear and kind of put it into a context, so that's going to be pretty handy for you. So the main idea of algebra and one of the main reasons we need to learn it is in school lies in this chapter. Basically, algebra, we find patterns and relationships in data, generalize these patterns, and use the data to make predictions of future events. So we're going to use prior knowledge of slope and linear equations to predict the future very accurately. So this is going to go along with a little activity that we're going to do in class. So all states in the District of Columbia have enacted laws setting 21 as the minimum drinking age. The table shows the estimated cumulative number of lives these laws have saved by reducing traffic fatalities. So where we start is we start by plotting the information. Let the year be X, let the lives be Y, and we'll take a look. So in 1999, 19.1 lives were saved. So I would guesstimate that to be about there. In 2000, it was exactly 20. In 2001, it was 21. In 2002, it was 21.9. In 2003, it was 22.8. So you can kind of sketch a line of best fit right through there. All right. So describe the correlation. So the number of years that have gone by since these laws have been enacted, what is the correlation? Well, I would call the correlation positive. I'm calling it positive. I'm calling it positive not because, we've saved more lives, although that's a positive thing too. I'm calling it positive because the trend of the line goes upward. That's why I'm calling it positive. Okay, so if I wanted to draw a prediction equation, I could do that, and what I would want to do is kind of take two of the points that I believe are on this line and kind of write my equation from there. Or if I can, I want to take kind of my best guess from my line that I sketched out. Hopefully yours is a lot cleaner than mine. So if I wanted to, just take these 2 points and write a prediction equation, I could do that. All right, so although this would probably not be the best points to use. Let's regraph this quick. So 1999, 19.1, 2000, 20, 2001, 21, 2002, I'm a year off. One more time, third time's a charm. I promise I'm getting better at this. So you're looking at something like that. So if I want my prediction equation. So according to the line I just sketched, my second and my fourth point are about on the line. So my second point and my fourth point are about on the line. So let's kind of use these 2 points and calculate a prediction equation. So again, just kind of taking what I had before. So this will be 1.9 over 2. So that'll be my slope, which is really, really close to 1, but not exactly. So that's going to be my slope. I'm going to use that and use one of the points. So I'll use 20 and 2000. 20 and 1.9 over 2, not 20, x minus 2002, or 2000. So y minus 20, 1.9 over 2x minus, this ends up being 1,000 times 1.9, so it ends up being about 1,900. Add 20. So my equation ends up being y equals 1.9 over 2x minus 1880. There's my prediction equation. So now use that prediction equation. How many lives are going to be saved in the year 2015? So 2015 is my x. So that's the way I treat it. I'm going to put this in for x and see what happens. So there's my calculator. So I'll take 1.9 divided by 2 times 2015 minus 1880. So 34.25. But remember, 34.25 is this value here in thousands. So 34.25 will be somewhere over here along this line. So I keep this line going, it'll probably hit there. So that is kind of my best guess. 34, what I have? 34.25 thousand lives. So using that, you can kind of predict what happens. So now, take a look. One of three things can happen, all right? You've got positive correlation, you've got negative correlation, or you've got absolutely no correlation. And the way that works is that there's kind of a feel to it to where you've got to look at what's going on, all right? I mean, I might have something like this. Yeah, generally it's positive, but it's very, very spread out. I mean, you could almost make an argument that there's no correlation too. All right, same idea. But if it's really, really close like this or really, really close like this, yeah, you can make a generalization. All right, and the line of fit, the prediction equation, is basically what is your line of best fit in y equals mx plus b form. All right, so it's kind of you're running what's called a regression to figure out how close your line is to the data. So the table shows the amount of time 5 students studied for their AP Euro exam and the grades each of them received. So let's make a scatter plot for this data. So let the hours studied be X, let the exam grade be Y. So let's go by twos. 2, 4, 6, 8, 10, 12. The exam grade, we'll start at 50. We'll go 60, 70, 80. Nope, can't do that. Let's just go every other one. So let's go 50, 60, 70, 80, 90, 100. All right, so the hours studied. For 5 hours, they got an 80%. So 5 is right here, 80 is right here. At 9 hours, they got a 95. So at 9 hours, 95. 3 hours, got a 75. 12 hours, got a 98. 1 hour, got a 70. So if I find the following information for the line of regression, so if I run this right there, kind of what's my slope looking like, or at least what's it very, very close to? Well, depending on how you draw your line, you can be a little bit clearer than I am. But I would kind of best guess, again, this has got a kind of a feel to it, is that I'm going to have a slope of 1/2. All right, or actually it's going to be a slope. Technically, I'm going up 10 and going over 4. See, I'm going up 10 points, going over 4 hours. All right, so my slope is actually going to be 10 over 4. So what this is saying is that for every 4 hours I study, I would get 10% better on the quiz or on the test. Okay, so my y-intercept looks to be about 68. So my equation for this simplified is going to be y equals 5/2 x plus 68. So what is your best guess? What do you think that a student who goes for studies for 10 hours will do? Well, throw 10 in there. So that's going to be 25 plus 68. So that's going to be 93. So that's what my equation gives me. Let's see if the graph marks matches up. At 10, I got a 93. That's pretty close. That's a pretty good estimate of what's going on. That's what we're trying to do. Okay, now you can do it both ways. I've shown you two ways to do it. You can either pick your points and try and work from there, or like I did, I tried to use the graph to do it. All right, so this table shows a total attendance for minor league baseball in a couple recent years. Let's make a scatter plot. So let's sketch this out. So you got 85, 90, 95, 2000. So there's your time, and here's your attendance in millions. So this will be your X, this will be your Y. So if we go years, we'll go 5, 10, 15, 20. So this will be 85, 90, 95, 2000. Okay, so I'm starting like year 0 is 1980. So since I'm going from 18 to almost 40, so let's start with this. We'll go 18, 20, 22, 24, 26, 28, 20. No, that's not going to work. That scale's not going to work. All right, sorry, I moved the scale down here just so I had a little bit more room. So once again, 1985, 1990, 1995, 2000. So your attendance in 1985 was 18.4. So that's going to be roughly right about here. Again, this is not an exact science, but you try and get as close as you can. So 25, that's going to be roughly there. 33.1 in 1995 is going to be in that neighborhood, and 37.6 in 2000 is going to be in that neighborhood. So if I draw this line, let me change colors here. That's a pretty good line of best fit, I would think. So I don't really have a good graph to go off of, so I would say those 2 points are pretty much on my line. Those are my middle 2 points. So that's the ones I'm going to use to try and figure out what this is. So if I look at slope, I'm going to take 33.1 minus 25.2 over 1995 minus 1990. So that's going to be 5 up top. That's going to be 25. 7.9. All right, and if I keep this line going, I would say that my y-intercept is probably about 10. Or I can put this in, use a point, and use point slope form to figure this out. Okay, so that's my slope, 7.9 over 5. Let's put this into an equation. So if I go y minus 33.1 equals 7.9 over 5 times x minus 1995. Slight change, since down here I only use 5, 10, 15, and 20. Up here I should only use that same idea. So this was 5, this was 10. So there I'm still fine, but up here instead of 1995 I should have used 10, not 1995, because down here I called it 1995. All right, so same kind of idea. So I'm going to have y minus 33.1 equals 7.9 over 5x. I'm going to give myself a little room here. 7.9 over 5. That's a positive 5. X minus 79 over 5. Add 33.1 to both sides. So when I do that, I get y equals 7.9 over 5x plus 17.3. So 17.3 is my y-intercept. The equation is here. So predict the attendance for 2010. Well, if 2000 was 20, 2010 will be 30. So substitute 30 in. So when I do that, I get an answer of 64.7. So 64.7 million people will watch minor league baseball in 2010. I don't think it's quite that high. I think it tapered off at some point. All right, so a quick review. Earning the following scores on recent Algebra 2 test. So I want to let the calculator do a lot of the legwork for me on this. So real quick, here's all I do. I go to Stat, Edit. I go to L1. Then I'm going to put in my data. So I'm going to pause it, put in your data, I'll put in mine, and then we'll go from there. All right, so I've got all the data entered in. I'm still in L1. I should have 20 points or 20 pieces of data. That's what I got. So now quit out of there. Stat, Calc, one var stats, hit enter twice. There it all kicks up. So my mean is going to be 73.9. I'll bring that back up. And then scroll down to get the 5 pieces that I need. So minimum 19, maximum 94. Q1 69, Q3 85.5, median 76.5. Let's see, minimum 19. Where are my final pieces? Max 94, 85.5, 69. So max 94, 85.5, 69. All right, so take that. I apologize. I know this wasn't my best video, but this is 2.5 for you. Come talk to me if you have questions. Have a good day at Farmington, and we'll talk to you soon.